Good morning. My name is Narasimharao, lecturer in physics. Today I am explaining time period of a simple pendulum. First of all, what is a simple pendulum? A heavier point mass suspended by means of inextensible massless string we are calling as the simple pendulum. The point where the simple pendulum is attached to this rigid support, this point we are calling as the point of suspension. In this diagram, S represents the point of suspension. In an ordinary language, a small metallic sphere suspended by means of inextensible cotton thread attached to the rigid support we are calling as the simple pendulum. Now this is the center of mass of the simple pendulum. This is the point of suspension. This small metal sphere we are calling as a bob. This is the center of mass of the simple pendulum, or it is the center of gravity of the simple pendulum. In the case of the symmetrical bodies, center of mass and the center of gravity both are coinciding. The distance between the point of suspension to the center of mass of the sphere we are calling as the length of the pendulum. It is represented by the letter L. The length of the pendulum may be 50 centimeter. The length of the pendulum may be 60 centimeter. The length of the pendulum may be 70 centimeter. The length of the pendulum may be 1 meter. Now I will show one arrangement. Now this is the small metallic sphere suspended by the inextensible thread. This arrangement we are calling as the simple pendulum. Now this simple pendulum is pulled aside and left free. It is making to and fro simple harmonic oscillations. It is making to and fro oscillations. It is one example. Initially, the simple pendulum is hanging vertically. Weight of this simple pendulum is acting vertically downward. Weight is represented by mg, where m represents the mass of the sphere, where small g represents the acceleration due to gravity. Weight of this simple pendulum is acting vertically downward. Now this is the cotton thread. Cotton thread is pulling the bob vertically up. This pulling force we are calling as a tension. Now this weight of this simple pendulum is balanced by the tension in the string. Now this simple pendulum is in the equilibrium position, or another name is in the mean position. Here, resultant force acting on this simple pendulum is 0. Weight of the pendulum is acting vertically downward. This weight is balanced by the tension in the string, which is acting towards the point of suspension. This position we are calling as the mean position or equilibrium position. Here this position we are calling as the mean position. Now, simple pendulum is pulled aside with some force. The simple pendulum is pulled aside through a small distance and left free. The simple pendulum is pulled aside and left free. It is making to and fro oscillations about the mean position along the circular path. Initially, the simple pendulum is at the mean position. After 1 second, the simple pendulum comes to here. After 2 seconds, the simple pendulum is coming to here. After some time, t seconds, the simple pendulum is coming to the point P. P is any point on this path. At the point P, weight of the simple pendulum is acting vertically downward. Now this is the cotton thread. The tension in the string is acting along PS direction. The tension in the string is acting along PS direction. The tension is acting towards the point of suspension. This weight of this simple pendulum or weight of the small metal sphere or the weight of the bob is mg. It is acting vertically downward. Here, this simple pendulum is making small angle with the vertical direction. Here, this angle is theta, means this angle is also theta. The reason is these two are alternate angles. Here, this angle is theta, means this angle is also theta. Now, please listen. This weight of the simple pendulum or weight of the small sphere or weight of the bob is mg, which is acting vertically downward. This weight of the bob or weight of the simple pendulum is divided into two perpendicular components. One is mg cos theta, another one is mg sin theta. For this angle, it is adjacent side. For that reason, it is mg cos theta. Remaining is mg sin theta, which is acting along PO direction, along the tangent to this arc. At this point, weight is divided at the point P. Weight of the pendulum is divided into two perpendicular components. One is mg cos theta, another one mg sin theta. Mg cos theta is acting along PM direction. Mg sin theta is acting along PN direction, along the arc, along the tangent to this arc. Now please listen here. This mg cos theta was balanced by the tension T2 in the string. But this mg sin theta is pulling the bob. This mg sin theta is pulling the bob towards the mean position. This mg sin theta is pulling the bob towards the mean position. This mg sin theta is trying. This mg sin theta is trying to bring this simple pendulum to this horizontal position. This mg sin theta we are calling as the restoring force. Mg sin theta we are calling as the restoring force. Mg cos theta was balanced by the tension in the string, that is T2. But this mg sin theta is unbalanced. It is not at all balanced. It is the unbalanced force. It is bringing the simple pendulum towards the mean position. This mg sin theta we are calling as a restoring force, otherwise unbalanced force. Unbalanced force. F is equals to mg sin theta. Mg sin theta. Here I am writing minus symbol. The reason is restoring force is acting towards the mean position. Displacement is along OP direction. Displacement of the bob is along OP direction. Restoring force is along PO direction. Both are opposite in direction. For that reason I have written minus symbol. That is, now this equation I am calling it as equation 1. Now, here, as the simple pendulum oscillating to and fro, as the the simple pendulum is moving towards the extreme position, velocity gradually decreases. As the simple pendulum is coming towards the mean position, velocity gradually increases. There is a change in velocity. Due to the change in velocity, this simple pendulum is having the acceleration. Simple pendulum is having the acceleration. Now, according to the Newton's second law, in the unbalanced force, F is equals to ma. According to the Newton's second law, unbalanced force F is equals to ma. F is equals to ma. F is equal to ma. That is equals to minus mg sine theta. M gets cancelled. A is equals to minus g into sine theta. G into sine theta. Here, in the case of simple harmonic motion, this simple pendulum is moving to and fro. The simple pendulum is moving to and fro. This amplitude must be very small. The amplitude must be very small. Here, amplitude is small means this angle is very small. In the case of small angles, sine theta is equal to theta. In the case of the smaller angles, if theta is very less than 10 degrees, if theta value is less than 10 degrees, if theta is very small, sine theta is nearly equal to theta. In the case of simple harmonic motion, the simple pendulum is oscillating to and fro. Now the amplitude must be very small. Amplitude is very small means this angle is very small. In the case of smaller angle, sin theta can be written as theta. This theta we are calling as angular displacement. Theta we are calling as the angular displacement. A is equals to minus g into, here this angle is very small, sin theta can be equal to theta, sin theta I am writing as theta. This equation is a change in the position. Initially the bob is at O. Now the bob of the pendulum is at P. It has traveled some distance along the straight line path. This distance along the straight line path we are calling as the linear displacement. Linear. Here the angle is very small. Here length of the arc is very small. We are considering it is the straight line distance. It is the straight line distance. It is the initially the bob of the simple pendulum is at O. Now after some time the bob of the simple pendulum is at P. It has traveled some distance. This small distance. It is the small distance. It is the small displacement OP. This small displacement OP I am taking as Y. Y is equal to OP. This is a small displacement. Now, when the simple pendulum is moving to and fro, you consider it is the circular path. Simple pendulum is moving to and fro. Just you consider it is the circular path. This is the circle in mathematics. It is the small portion of the circle. We are calling as the arc of the circle. It is the radius of the circle. Theta is the angle at the center. In our 10th class, there is a one relation. Angle theta is equals to length of the arc by radius. Now you can, it is the simple pendulum when it is oscillating to and fro. When it is oscillating to and fro, you consider it is the circle. This is the small portion of the circle. We are calling as the arc of the circle. Here, OP we are calling as the arc of the circle. theta is equals to length of the arc, nothing but OP. Length of the arc means OP. Now it is the circle. It is the circle means it is the radius. It is the circle. It is the circle means it is the radius. Radius is L. Radius is SO. That is equal to OP. Now here it is the small length of the arc. We are considering as the straight line distance. OP straight line distance, that is equal to Y. OP means Y. SO. SO is equals to length of the pendulum L. Length of the pendulum L. Now this I am considering as equation number 3. Substitute theta is equal to Y by L in the equation 2. Theta is equals to Y by L. Acceleration A is equal to minus G into theta. Theta means Y by L. Theta means Y by L. This can be written as A is equals to minus G by L into Y. It is equation number 4. Equation A is equals to minus G by L into Y. This equation I am calling it as a 4. In this equation, Y represents the displacement. Initially the simple bob of the simple pendulum is at O. After some time the bob is at P. There is a change in position along the straight line path. I am calling it as a displacement. This displacement I am taking it as a Y. Acceleration is in the numerator. Displacement is in the numerator. Acceleration is in the numerator. Y represents a displacement. Displacement is in numerator. Both are in a numerator. Acceleration is directly proportional to the displacement. And here minus symbol indicates acceleration and displacement both are in opposite direction. Simple harmonic motion means it has to follow 3 conditions. Number 1, the pendulum has to move to and fro about the mean position. Yes, it is following. The simple pendulum is moving to and fro about the mean position. Number 1. Number 2, acceleration is proportional to the displacement. Following. Number 3, acceleration and displacement are opposite in direction. The motion of the simple pendulum is the simple harmonic motion. The simple pendulum is making simple harmonic motion about the mean position. About the mean position. In a simple harmonic motion, there is a standard equation for acceleration. In a simple harmonic motion, there is a standard equation for acceleration. That is, A is equals to minus omega square Y. It is the equation number 5. It is the standard equation for acceleration in simple harmonic motion. Now please listen here. Equation 4 and equation 5. It is representing acceleration. It is also representing acceleration. Right? Now here, you compare these 2 equations. Now A equal, minus equal, Y equal. You compare these 2. You are comparing black person and white person, short person and a tall person, flat person and a thin person. Like this you compare. A equal, is equal to equal, minus equal, Y equal, omega square is equals to G by L. On comparing equations 4 and 5. Now you compare these 2. A equal, minus equal, Y equal, omega square is equal to G by L. Omega square is equals to G by L. Omega represents angular velocity. Omega represents angular velocity. Here, omega square is equal to g by l. That implies omega is equals to under root of g by l, where l represents the length of the pendulum, small g represents the acceleration due to gravity. We are having one formula, angular velocity. We are having one formula, omega is equals to 2 pi by capital T, where capital T represents the time period. Capital T represents the time period. Time period means what? The time taken by this simple pendulum to complete one oscillation, we are calling as a time period. Time period means what? The time taken by this simple pendulum to complete one oscillation, we are calling as a time period. Now, omega is equal to 2 pi by t. In the place of omega, I am writing 2 pi by capital T, that is equals to under root of g by l. Now reversing the order 2 pi by t, I am writing as t by 2 pi, that is equal to reversing the order under root of l by g. 2 pi goes to numerator, t is equals to 2 pi into under root of l by g. Now this is the expression for the time period of the simple pendulum. Time period of the simple pendulum, where L represents the length of the simple pendulum, G represents the acceleration due to gravity.